Well, I was asked if I could do a little video about alternators and a little bit about how they work, so I'm going to go ahead and explain a bit of the principle behind them and show you the parts and what they do. And I guess the first thing you should know is the basic two principles behind them. And one is, if you run a magnet across a piece of wire, it will induce a voltage into that wire. And the other thing is, if you run power or current through a wire, it will create a magnetic field. And those are the two basic principles that the alternators work on. So I guess we'll get into the parts here. And the first part I'm going to explain is the rotor, which is this piece. It sits inside there. And what the rotor is basically a big electromagnet. It has two sort of like claws or fingers, one on each side, and they basically create the opposite ends of the magnetic field. One side will be all north and one side will be all south. And basically what the magnetic field does, if you kind of imagine, it comes from one side and goes off to the other one, kind of makes an imaginary little bubble, and it does the same going the other way. And to get that electromagnetic field, there's a coil of wire inside this, and these slip rings here are where the power comes in through a set of brushes. And that's basically all a rotor is. This thing spins inside here, and there's of course a bearing in the front part of it and a bearing in the back right there, and those are the brushes you can see, and they attach the voltage regulator, but we'll get into that later. And that's basically what a rotor does. And the next part you're going to have is the stator. I can't really pull this one out, but as you can see, it's just 3 coils of wire wrapped around in a certain way. And what this will do is will actually be the part that the voltage is induced into by the rotor. And this is actually where the output of the alternator comes from. Pretty simple. There are 2 different styles, I believe, that the way these are wound. One is a Y winding and one is a I believe it's a delta winding. I have a little picture here in a book. This is a great book, by the way, if you want to learn about cars and how the systems work. But here's a little picture of how they're wound. You don't really need to know that. There's the delta connection and the Y connection, and basically those 2 different windings have to do with the output at low speed and the maximum output of the alternator, but I won't get into that too much. Now the ends of these stator windings go to a diode rectifier, which let's see if I can find one with a good one that you can see. There's not really a good example, but there's basically diodes in here and a heat sink, because those little diodes get hot. And what the diodes do is they're like a one-way check valve. They allow electricity only going one way. So basically you'll have the negative diodes there that will allow the negative to ground to the case of the alternator, and you'll have the positive ones which will allow current to flow out the output terminal of the alternator. Let's see, what else is there? You've got the voltage regulator, which you can see sort of right in here, and you can see it in the back of pretty much all of these, except for these ones. These ones are externally voltage regulated. But the voltage regulator back there, or excuse me, that's a diode rectifier. Voltage regulator is right here with all the plug-ins. And what that does is it basically monitors the output of the alternator, and it decides whether to add more current to the rotor or less. And the more current you add, obviously the stronger the magnetic field will become in this rotor. And once that happens, more voltage will be induced into these stator windings, and you'll get a higher output for your alternator. So if you've got a low battery or got a lot of accessories on, it will automatically up the output of your alternator to whatever the maximum is. And those are the basic parts. Obviously there's bearings and whatnot too, but those are the basic parts of an alternator. Alright, now that I've kind of shown you what all the parts are to the alternators, the different parts, and explained a little bit about how they work, I figured we'd talk a little bit about how these are regulated. The newer style have a voltage regulator in them, little magic box, electronic box that does all the work for you. But the older style ones, like these two, which are out of a Chrysler, are externally voltage regulated, and they will have either something like this, which is a mechanical regulator, or they will have a little electronic one that'll sit up on the firewall, and it basically works the same as these ones. It's just on the firewall and not in the alternator. But here I've got this off to kind of show you what it does, and basically all it does is turn on or off the rotor. Basically put a magnetic field in it or no magnetic field, and it kind of switches back and forth like that. It's got a little electromagnet in there, pulls that down when it needs to and turns it on and off. These you won't see. They're probably phased them out around 1970. So they weren't around very long. You won't see these nowadays. And I don't have an electronic one that's externally voltage regulated. Well, I do, but they're probably on a car somewhere. And that brings us basically to the internally voltage regulated ones. Let's see here. I have a Ford, which shows it really good because you can take it right off. And usually I don't replace voltage regulators. If the alternator doesn't work because of the voltage regulator, 9 times out of 10 I'll just get another alternator, rebuilt one, because a lot of times, not always, but a lot of times these voltage regulators are rather expensive. So let's say a voltage regulator is $50 and you can get a rebuilt alternator for $70. I just go with a rebuilt alternator because it's just easier. Same thing with most anything that goes wrong with these things. I don't really rebuild them. The bearings, if they go out, I usually just get new ones. You can take them apart and fix them and replace bearings and whatnot, but generally I don't do it because it's not worth the hassle most of the time. But those are the different styles of regulator. I don't know what else to talk about here. Pretty much covered everything, I think, except about how they're wired. Generally speaking, there's a million different ways to wire these things up. So if you have questions about wiring and how your alternator is wired, I would try Google and see if you can find a wiring diagram, because they're all a little bit different. I mean, they all have the big output, but as far as the inside, they're usually different, and different plugs. There's four wires there. I think the Ford one here has 3. There's 4 in that one. These two I think are the same. There's 4 in that one. And this one you've got, obviously you've got 2 field connections. And this one you've only got 1 because it's grounded to the case. It's just a bunch of different little styles. This one's got basically a plug for 4, but 3 of these are plugged off and only 1 comes out. So, they're all a little bit different. So if you got questions, Google is a good place to go to figure out how your car is wired up. Now, things that can go wrong with alternators. The main things that can go out are the bearings, obviously. Let's see if I even have a bearing. Oh, there's one in there. They can get squeaky, they can wear out and go bad. I've seen diode trios go out. And when they go out, they will either completely go out, or you'll have one that'll go out, and then you'll get more AC voltage coming out of your alternator, which is bad for the battery. So if that happens, you'll have a lower output, and you may ruin a battery, I've heard. And I've also heard that a battery with a dead cell will also ruin an alternator, because the alternators are trying to put out at full power all the time to make up for that dead cell, and that'll fry the alternator. So you know, it's kind of a catch-22. You put a new alternator in, but the battery's still bad, and you fry the alternator, so you switch the battery out thinking it's that, and put a new battery in it, and it fries the battery from all the AC voltage coming out of the battery, or out of the alternator. So yeah, you better check that. I think that was a main problem on the high output alternators, but I've just heard that. I've never experienced it. Another thing that can go wrong is these brushes. They can wear out, but I usually don't find them to be the problem. They usually last a really long time because there's not a ton of power running through these brushes to the slip rings into the rotor like there is in a generator setup. There's a lot more power going through those little brushes. Usually you don't have too much trouble with the stator or the rotor itself. I have seen one actually melted, though. It melted at the diodes. Oh, there they are. That's a good little shot. You can see how that's wired up. And another thing that can cause, obviously, alternator not to work is a voltage regulator. And any wiring to it. If you have dirty connections here or at the plug, or the alternator doesn't ground properly, you can have an alternator that doesn't work. And the other thing that's often overlooked, and I've overlooked it at times myself, is the belt and the belt tension. If your belt's not on there nice and tight the way it should be, the belt can slip on the alternator and it won't put out what it needs to put out. So I think I've covered just about everything I need to cover here, so I hope you learned something, or at least enjoyed me talking. Well, I figured real quick I'd add to the end of this video. This book is Automotive Service by Tim Gills. You can usually get these for maybe 50 bucks nowadays, but they're really good if you want to learn anything about cars, how they work, how the different components work. There's tons of pictures, tons of little diagrams. They explain everything in great detail. So I've even used this if I come across something I've never seen before. I'll throw it, look it up in this book, and usually it'll have it. It's a great thing to have. So I recommend, if you're learning, to go out and get one of these.